Welcome to the second lecture in the module 4 in the subject hydrology and water resources. So, in the previous class we have started talking about the runoff, and we said that hydrographs are one of the important tools that helps us to understand or quantify the value of runoff. Okay, so in the same sequence we will talk about hydrographs. So let's say when water flows inside a catchment or inside a basin, how these hydrographs are affected by the shape of basin. Okay, so broadly I will write the topic as factors affecting shape of hydrograph. Okay, so what are the factors that affects the shape of your hydrograph? So first one is, let's say the first one is shape of basin. Okay, shape of basin means shape of catchment area. What is the shape of your catchment area? So how this can affect? So let's say if your catchment area is like this, okay, if your catchment area is like this and this is your gauge station where you are doing all your calculation, and let us say this is your stream. So what will happen in this situation? Water will be flowing like this, like this, like this. Okay, water will be flowing like this and it will be observed here. So if you draw the hydrograph, okay, if you will draw the hydrograph, you could observe that the later part or this side of the catchment is slightly broader. Okay, so water will fall more in this portion and it will take longer time to reach your gauge station, which can also be said that the peak in the hydrograph will be late. Okay, the peak of the hydrograph will be late because more water is coming from broader area and which is too far from your gauge station. Okay, so hydrograph will be like this. But what happens if the shape of catchment is not like this, or rather it is like this? Okay, the shape of catchment is like this, and let us say this is your stream and this is your gauge station. Okay, if it is like this and there is precipitation, then water will join the stream like this. रेनफॉल के बाद पानी यहाँ से आएगा, and since this side is broader, so more water will be coming from this side. Okay, more water will be coming from this side and it will quickly reach the gauge station, which means the peak discharge will be very early. So if you want to compare both the hydrographs, so the hydrograph for this will be like this. here the peak is late peak. Okay. Here it is early peak. Okay. So it all depends on how is the shape of your catchment area, or how is the shape of basin. Then what can be other important thing, or what is the other possibility? So there can be a number of possibility. We are just listing few of them. So let's say your catchment area is like this. Your catchment area is like this, and let's say this is your stream, okay, and this is your gauge station. So when rainfall will happen in this catchment area, water will be flowing like this. So water will be flowing like this, and you have set up your gauge station here. So how the hydrograph will be? So if you see here, hydrograph will be something like this. Okay. The graph will have two peaks. This is your first peak, this is your second peak. So hydrograph will have two peaks. Why the hydrograph have two peaks? Because of this shape. Okay? When water will be coming from this portion to here, it will give first peak, and when water from this portion of catchment also start contributing, then discharge in the hydrograph will again increase. So the shape will be having two peaks. Okay, two peaks. So likewise there can be many interpretations. Okay, you can predict many things about the hydrograph just by looking the shape of your catchment area or the shape of your basin. Now, but the shape itself is not a parameter which you can explain. Okay, you cannot explain it mathematically. Okay, until and unless it is a very regular shape. For example, if it is a rectangle, you can say that it is a rectangle. But for practical purpose, the catchment area is totally a irregular shape. It has an irregular shape, so it becomes very difficult to explain these shapes. So now you want to explain those shapes mathematically. Okay, so what can be your parameters to explain these shapes? So let me change this one. So it is like how to quantify shape of point, that they call it as form factor. Okay, they calculate form factor for the catchment, and they say that this is a mathematical value which will be explaining your shape of basin. So what is this form factor? It is represented by the letter F, and it is the ratio of width of catchment area and axial length of catchment area. Okay, so they calculate the width and they calculate the axial length, and basically this is the average width. Okay, this is the average width and the axial length. So this is, they calculate, they have the catchment, they averaged all the width and they calculate one average width. Okay, then they divide it by the length and they calculate some numerical value, and this numerical value is somehow is related to the shape of your basin. Okay, so this is one parameter. Another parameter is called compaction factor. So what is compaction factor? So compaction factor is like this. If there is some catchment area is like this, okay, so what they will do, if this catchment area have area, let us say A, now what they will do, they will draw one circle. Okay, they will draw one circle which have area same as this catchment. Okay, same as this basin. They will draw a circle which have this same. Okay, so they will calculate and they will draw the circle, and then they will find the ratio of perimeter of basin, okay, and perimeter of this circle, and this ratio they refer it as compaction factor. Okay, so these two factors roughly depicts the shape of your basin. Although there can be a number of such formation which can be used, okay, depending on the requirement and situations. Okay, now sometimes they directly says that the form factor, the compaction factor affects the shape of a hydrograph. Okay, let me repeat. If the statement is like this, form factor and compaction factor affects the hydrograph, okay, or the shape of hydrograph. So is this statement right? Yes, it is perfectly right. Why? Because these factors are nothing but a mathematical value which basically related to the shape of your basin. Okay, and shape of basin itself decides the shape of your hydrograph. So these two factors are also affecting the shape of hydrograph. Okay, apart from that, there can be more factors which can affect the hydrograph. So let's go to the second point. Second point is stream density. Okay, so what is stream density? So let's say if the catchment area is like this or basin is like this, in this basin there is your main stream, okay, and very small, so this is your main stream, and in this main stream is contributed water by the smaller streams. Okay. So what is stream density? So stream density is number of streams per unit area of catchment. So stream density is the second factor which is affecting your shape of hydrograph. The first factor was shape of basin. Then after what can be another point? Third can be size of catchment. Okay, कैचमेंट का साइज कितना ज्यादा है ये भी क्या करेगा, शेप को डिटरमाइन करेगा. A rough prediction is like this कि discharge of hydrograph is directly proportional to the area with some power n. Okay, so that n depends on various factors depending on what type of catchment area it is. Okay, and so many factors determine this n. Okay, so this can be your third point. So there can be a number of things like wind, or let's say wind direction. Wind direction will also affect the shape of hydrograph. Then what can be another thing? It can be slope of catchment. Likewise, there can be a number of things. Vegetation can be there. What kind of forest is there? What kind of land cover is there? Okay, how many number of mountain is there? What is the contour of that area? So these are the various factors that will be affecting the shape of hydrograph. Okay, now we roughly knows about hydrograph. Okay, let's move one step ahead and let's again talk about your runoff. So let's again talk about runoffs. So the runoff, okay, when you draw the hydrograph, so you see that runoff is basically divided in two parts. The hydrograph is basically divided in two parts. Okay, so if you could remember, your hydrograph is like this. Okay? So this much portion is your base flow and another is your runoff. Okay, so the runoff is basically divided in two parts. The first part is called direct runoff and second is called your base flow. Okay, so this part of hydrograph, okay, this unshaded part is your direct runoff and this shaded part is your base flow. Okay, so what do you basically mean or what do you basically depict from this word direct runoff? So let me draw a diagram again. Let's say this is some mountain and this is some river. Okay. So if there is some rainfall is happening, okay, some rainfall is happening. So what will happen? Some of the water will be falling on the earth's surface and some of the water will be going inside the earth as a groundwater. Some of the water will be flowing. Okay, let me change the color. Okay, so some of the water will be flowing like this and this water will join this stream. Okay, so okay, and another important thing is some of the water which is going inside the earth, okay, it will be flowing inside the earth and it is joining this stream. It will be joining this stream inside the earth. Okay, so all this water and this water is coming to this stream. Okay, so coming to this stream. So what you are doing, you have set up one gauge station inside at some location in the stream, and you are reading this runoff. So if you could see here that this direct runoff, okay, is made of three things. This one, precipitation, okay, or let's say rainfall. The water that is flowing over the surface, so that we call this water as surface runoff. Okay. And the water that is flowing inside the earth and joining the stream, we call it as prompt interflow. Okay, so it is made of rainfall plus your surface runoff, and third one is your prompt interflow. So these three factors will be giving the value of direct runoff. And the base flow is the water that is coming from the origin or the ground water. Okay, river जो flow हो रही है, अगर बारिश नहीं हो रही है एक पर्टिकुलर ड्यूरेशन में, तो उस रिवर में पानी कहाँ से आ रहा है? Okay, तो उसका कुछ ओरिजिन होगा जहाँ से वो कंटिन्यूसली पानी आ रहा है. लेट से एक लेक है या रिजर्वायर है. Okay, so that value of discharge is nothing but your base flow. Okay, the source can be many. It can be groundwater, it can be glacier, it can be some reservoir. Okay, it depends on that particular stream. So this is about your runoff. So this is all about runoff. Now we have to talk about the unit hydrographs. So we will talk about unit hydrograph in our next lecture. So thank you very much.